Hi everyone, Ryan here, and today I'm going to show you how to build version 2 of the coin pusher. Not a lot has changed, but what has changed is I've refined some things about the body, made it a little bit more robust, built in some flexibility, like instead of just using a stepper motor to drive the dozer part, you can use a hand crank, so no electronics required, or a standard servo motor. So some flexibility is built into there. It's also a little bit smaller, just really for me, so it fits in certain standard size shipping boxes. And I decided to redo the video because just to keep things consistent with the model that's posted on the website and the assembly video of how to put it together so they match. So without further ado, I'll show you how it's done. Okay, get all your pieces and parts, lay them out, identify them. There's a ton, sorry. First thing we're going to do is glue together the coin dozer part, the top and bottom. Make sure to line this up as best as possible. Get a good even glue, since this is one of the few mechanical parts that, moves and some precision is required when gluing it together. Next, we're going to glue the two stack ups that contain any coins that are caught by the house cutout holes. And then get the main coin floor and a bunch of nuts and bolts, which is a mix of metric and imperial because I don't know how to make things simple, and we're going to start populating the parts for that. These are the flange bearings for M5 bolts, and we're going to space them with some shim washers since the varying thicknesses of plywoods that I'll usually use for this kit will need 1 or 2 shim washers so the flange just captures or clips the top and keeps it sandwiched into this floor. So these are oval cutouts, so there's a fudge factor built in for varying thicknesses and different shim washers. And we're going to retain these with a larger washer on the bottom. You don't have to crank this down yet because we still have to fit it later. So there's all 4 installed. Wow. And you can see the little flange should just capture the coin dozer. Next, you'll find these spacers with a specific cutout meant for the locking nut on the side. And we're going to use a business card to shim these up because we don't want that top scrapey part to be the same height as the dozer pusher. Then we can put the side brackets in, and you can see that these are interchangeable depending if you want the house to be able to win coins or not. Next, get the Plinko board, remove the plastic, and take note of where the notch is. That notch is for the LED wires on the top. And I'm gonna use some perler beads. Okay. And these are good these are the cheapest Imperial number 4 size spacer that I can find. And if we all had our times with the beads. You can see how this is going to go. I'm only going to do a few perler beads in certain areas. It's kind of infuriating if you were to do all of them because they'll start moving around. And only these are really going to keep the playfield Plinko board plexi from sinking in too far once these are tightened down. Now I'm going to put nuts and bolts on the outside to hold the main stack up, but I'm too lazy to put nuts on every single one of these, so I'm just going to use rubber bands. And this actually works a little bit better than the nuts because when transporting this machine, just general vibrations will loosen those nuts up anyway. So these 2 assemblies we've made, plus the bottom part of where the coins drop, we're going to insert that there. And if things keep falling and you're frustrated, that means you're doing it correctly because there's just not an easy way to do this. Then we'll put the other side of the body on, and there's 2 little nuts or 2 little holes for nuts and bolts inserts that kind of lock everything together. So go ahead and do that here. And everything should be held together pretty loosely, and it should start to look like a coin pusher. We'll also put the front on because it looks good. Oh, it's methodical. And next you can remove the protective plastic for the acrylic windows on the side and put the nuts and bolts in there. So now the dozer part should be dry, and we're gonna fit it. So once you get it dead center on the board, clamp it down, and we're going to tighten the bearings to lock it in place. So it should move back and forth pretty easily, and then there's no issue. Okay, so this kit comes with 3 different plates. The first plate I showed you is for a stepper motor. Then you have the hand crank or the servo. And to do the servo, some servos have a little nub in the plastic for the servo body mount, and we have to Dremel this out from the bottom of the top servo mounting plate. So you can see once that's Dremeled out, it should sit flush. You don't have to do this, but I recommend it. And then I'm going to drill out 2 servo mounting holes so I can mount the servo into this bracket. Next, I'm going to hot glue the smaller driving gear to the top of a servo horn, and I've countersunk the back of this just so it sits flush over the raised nub on some of these servo horns. And this is a continuous rotation servo. You can use a 180-degree servo motor just with modified code. Next, I'm going to take this long, I think 80mm bolt, and I'm going to crank down on a nut to lock this gear in place. I'm going to finish doing the top assembly stack of the servo-driven part. And you can see there's a little cutout where the servo wires can pass through. And I'm going to use my spacers and then my hex standoffs to lock this in place, and then put the other bearing mounted on the bottom, and these just press fit in. And so you can see there's a bearing in the top too. Next, I'm going to take this spacer so I can get the gear at the same level as the servo gears, and this should work pretty loosely right now. So this is the stirring stick, or like the camshaft, and there's 2 different versions that come with it since, you know, fudge factor. If you use a thicker bolt, you might need to move that bolt towards the center of rotation. And I've just locked that in with a nut and then 2 sandwiching nuts on that actual camshaft. So make sure to tighten down on this. Now, when I was putting this together, I actually needed to shim this bolt up, like either cut the bolt by like 4mm or just shim it upward so that camshaft doesn't poke all the way through from like the stirring part. And you'll see what that clearance looks like when we put it together. So take that whole stack and stick it on top of the main body, and we're going to use some bolts to secure the motor driven part. And if we turn this, everything should move freely. And you can see the cam part moving the dozer. And where that bottom lock nut is on the central shaft, we want to make sure that clears the pushing dozer part. Okay, so if you don't want to do this with the servo motor, we can do the hand crank version. And this is what that hand crank version looks like. So you can make a knob, 3D print a knob if you want. But there's just a hole cut out in this disc so you can do it. And the assembly is pretty much the same. If I do this in one take, I'm going to eat this chocolate bar that I'm staring at. Okay, so that looks just fine. And again, it mounts the same as the servo motor. And you use the bottom bolts to lock this in place, and that's your hand powered thing. So it works just the same. You can even stick your finger in there and do it. And then there's a big cutout on the back of the body so you can button this all up and still get access to this hand crank. So there's the dozer in action, and we'll get an undershot of how that circular motion, when it's constricted into one axis, essentially pushes this just up and down in the opposite axis. So neat, I guess. And then use the rest of the nuts and bolts to lock this into place. Next, we're going to mount the top part of the coin pusher just with a couple bolts, and then place a front on. And this is to mark holes for the piano hinge. You don't have to use a piano hinge. You can use whatever hinge you have. but the piano hinges sold in big box stores in the US are done in the hinge parts are done in 1/2-inch increments. So when you cut them, it will match this coin pusher very well, since I modeled this coin pusher in 1/2-inch increments. So that's nice. Sorry for everyone else outside the US. So I'm making a pencil line with the top on underneath, and this represents where the front of the acrylic plate is and where that little notch is, so we can have wires pass through when we mount our LED strips. These are just the generic LED strips that I'm mounting. Both are connected, and then you can see where that notch is, our wires will pass through unobstructed. I've also mounted the window to the front panel of the coin pusher and just popped in the bolts for the piano hinge. So now I'll put the top on in place and put all those nuts and bolts in. So this is the front chute that whatever coins are knocked over the edge, they just get pushed out to the front. And we have some little semi-triangles that are actually what's left over from the house cutouts. And these just funnel them through the front cutout, and these are glued in. So make sure you place these in dry, mark where they're supposed to go, since they're going to be shifted up a little, since the back thing is at an angle, and then glue those in place. This is the bottom of the coin pusher, and I've glued some extra parts that are the feet for this thing. Now I'm going to take those little containment parts and bolt them in. This is underneath the cutouts for the house when coins fall in, and the house would essentially win these coins. These are, I think, Gerber baby food cups that I saved when I had my wisdom teeth out. They're nice for holding parts, and they also fit in here pretty well, so that's essentially what I made them for. I'm placing the finished or nearly finished coin pusher body on top of this, and then I'm going to populate some more of the electronics like the button. Now let's talk about the LCD. I'm using a 16:2 LCD character display, or 2x16, whatever. And I'm going to use a I2C backpack for this, since I don't want 10 wires coming from the top. Now this backpack has a header that pokes out in the wrong direction, so I had to remove that header and essentially put a different one that is angled or points inward, so I can get my 4 connection wires into that. Now this backpack it's pretty deep, and there's some continuity issues with building this, but to get that LCD to sit flush, I got to Dremel out another part of the front, and then I've glued some of these sandwich stacks to the front plate of this LCD panel. I'm going to thread my wires through the top portion and put that in there. So continuity wise, I've got to go cut the back plate to make this fit. I'm going to revise this in the final version of the coin pusher, but so you know what's going on. This is optional. This is the tilt sensor, and this comes from old pinball equipment where I got this. You can make your own with a bolt and a large size washer. So I have an LED wired with a resistor in series with this wiring, plus another 2 wire terminations for the actual switch of this button. LED is optional. And I'm going to install that into the top panel. All the wiring from the top panel needs to be threaded through the cutouts on the bottom plane. And we can do that here. Make sure you wire wrap some of these because you don't want this happening, which is bad. Next, upload the code that's on the website, and the description of that code is on the webpage too, to your Arduino. Now I'm using a custom Arduino, so if you follow this schematic, you have to be careful that the regulator on regular Arduinos isn't beefy enough to take 12 volts down to 5 volts and dissipate that power effectively. So just note that. This is a visual representation of what's wired what, but I'm using a custom Arduino that I did. So you can see the LCD backpack, all the buttons, the servo, the tilt switch, and the ready light blinking on it. And here's that custom Arduino that I've got screw terminals on to make all the wire terminations quick and easy. So wire your Arduino or your microcontroller up however you see fit. And then you're gonna stuff that into the bottom of the coin pusher. Now, I would mount that if I was you, but just to get this video through, I'm not mounting it, but you should do that. This is the rear panel, so I have a DC jack with a switch interrupting that input supply, and we're just going to connect that in series with the switch, and then that DC jack connects to this custom Arduino that I made. And mount that to the rear, and you can button things up, and you're done. Okay, so I lied. We still have to do the LCD mounting part. I had to cut out a hole on this bracket because in this version I'm still finalizing the design. The final design is this issue has been fixed in the kit, but we still have to button it up with the 2 screws in the front that holds the stack together, and then a final nut and bolt from the bottom that keeps this stack attached to the cabinet body. Once you've done that, now you're done.